Exploratory Data Analytics. What is exploratory data analysis? Exploratory data analysis is an approach, in analyzing datasets, to summarize their main characteristics, often using statistical graphics and other data visualization methods. It helps determine how best to manipulate data sources to get the answers you need, making it easier for data scientists to discover patterns, spot anomalies, test a hypothesis, or check assumptions. EDA is primarily used to see what data can reveal beyond the formal modeling or hypothesis testing task, and provides a better understanding of dataset variables and the relationships between them. It can also help determine if the statistical techniques you are considering for data analysis are appropriate. Originally developed by American mathematician John Tukey in the 1970s, EDA techniques continue to be a widely used method in the data discovery process today. EDA assists data science professionals in various ways. 1. Getting a better understanding of data. 2. Identifying various data patterns. 3. Getting a better understanding of the problem statement. Steps involved in exploratory data analysis. There are mainly 3 steps involved in exploratory data analysis. 1. Understand the variables in dataset. 2. Clean the data. 3. Analysis of relationship between variables. 1. Understand the variables in dataset. The very first step in exploratory data analysis is to identify the type of variables in the dataset. Variables are of 2 types. 1. Numerical. 2. Categorical. They can be further classified as follows. Dataset. Let us take the example of loan default dataset. In the above dataset, the numerical variables are, and the categorical variables are. Once the type of variables is identified, the next step is to identify the predictor, inputs, and target, output, variables. The target value is loan_default, and the rest 28 features can be assumed as the predictor variables. Importing libraries. Import pandas as PD. Import numpy as NP. Import matplotlib as PLT. Import cburn as SNS. Pandas library is a data analysis tool used for data manipulation, numpy for scientific computing, matplotlib and cburn for data visualization. Importing dataset. Let's import the dataset using the read_CSV method, and assign it to the variable train. Train equals pd.read_CSV, train.csv. Identification of data types. The .dtypes method is used to identify the data type of the variables in the dataset. Both date of birth and dispersal date are of the object type. We have to convert it to datetime type during data cleaning. Size of the dataset. We can get the size of the dataset using the .shape method. Statistical summary of numeric variables. Pandas describe method is used to view some basic statistical details like count, percentiles, mean, STD, and maximum value of a data frame or a series of numeric values. As it gives the count of each variable, we can identify the missing values using this method. Data cleaning. What is data cleaning? Data cleaning is the process of preparing data for analysis by weeding out information that is irrelevant or incorrect. This is generally data that can have a negative impact on the model or algorithm it is fed into by reinforcing a wrong notion. Data cleaning not only refers to removing chunks of unnecessary data, but it's also often associated with fixing incorrect information within the dataset and reducing duplicates. The importance of data cleaning. Data cleaning is a key step before any form of analysis can be made on it. Datasets and pipelines are often collected in small groups and merged before being fed into a model. Merging multiple datasets means that redundancies and duplicates are formed in the data, which then need to be removed. Also, incorrect and poorly collected datasets can often lead to models learning incorrect representations of the data, thereby reducing their decision-making powers. It's far from ideal. The reduction in model accuracy, however, is actually the least of the problems that can occur when unclean data is used directly. Models trained on raw datasets are forced to take in noise as information, and this can lead to accurate predictions when the noise is uniform within the training and testing set, only to fail when new, cleaner data is shown to it. Data cleaning is therefore an important part of any machine learning pipeline, and you should not ignore it. Data cleaning versus data transformation. As we've seen, data cleaning refers to the removal of unwanted data in the dataset before it's fed into the model. Data transformation, on the other hand, refers to the conversion or transformation of data into a format that makes processing easier. In data processing pipelines, the incoming data goes through a data cleansing phase before any form of transformation can occur. The data is then transformed, often going through stages like normalization and standardization before further processing takes place. How to clean data for machine learning. As research suggests, data cleaning is often the least enjoyable part of data science, and also the longest. Indeed, cleaning data is an arduous task that requires manually combing a large amount of data in order to a. Reject irrelevant information, b. Analyze whether a column needs to be dropped or not. Automation of the cleaning process usually requires an extensive experience in dealing with dirty data. It's kinda tricky to implement in a manner that doesn't bring about data loss. Data cleaning steps. There are 3 major data cleaning steps. 1. Remove duplicate or irrelevant data. 2. Filter out unwanted outliers. 3. Handle missing data. 1. Remove duplicate or irrelevant data. Data that's processed in the form of data frames often has duplicates across columns and rows that need to be filtered out. Duplicates can come about either from the same person participating in a survey more than once, or the survey itself having multiple fields on a similar topic, thereby eliciting a similar response in a large number of participants. Python syntax. pandas.dataframe.drop_duplicates. Dataframe.drop_duplicates. Subset equals none. Keep equals first and place equals false. Ignore _index equals false. Return data frame with duplicate rows removed. Considering certain columns as optional. Indexes, including time indexes, are ignored. Parameters. 1. Subset. Column label or sequence of labels, optional. Only consider certain columns for identifying duplicates. By default, use all of the columns. 2. Keep. First, last, false, default, first. Determines which duplicates, if any, to keep. 1. First. Drop duplicates except for the first occurrence. 2. Last. Drop duplicates except for the last occurrence. 3. False. Drop all duplicates. 3. In place. Bool. Default false. Whether to drop duplicates in place or to return a copy. Ignore _index. Bool. Default false. If true, the resulting axis will be labeled 0, 1, n1. Returns. Data frame or none. Data frame with duplicates removed or none if in place equals true. Examples. Consider dataset containing ramen rating. By default, it removes duplicate rows based on all columns. df.drop_duplicates. To remove duplicates on specific columns, use subset. df.drop_duplicates, subset equals brand. To remove duplicates and keep last occurrences, use keep. df.drop_duplicates, subset equals brand, style, keep equals last. 2. Filter out unwanted outliers. An outlier is an unusual observation that lies away from the majority of the data. Outliers can affect the performance of a machine learning model significantly. Hence, it becomes important to identify outliers and treat them. Let us take the life_sq column as an example. We will first use the describe method to look at the descriptive statistics and see if we can gather any information from it. df.life_square.describe. The output will look like this. From the output, it is clear that something is not correct. The max value seems to be abnormally large, compared to the mean and median values. Let us make a box plot of this data to get a better idea. df.life_square.plot, kind equals, box, fig size equals, 12, 8. plt.show. It is clear from the box plot that the observation corresponding to the maximum value, 7478, is an outlier in this data. Descriptive statistics, box plots, and scatter plots help us in identifying outliers in the data. We can deal with outliers, just like we dealt with missing values. We can either drop the observations that we think are outliers, or we can replace the outliers with suitable values, or we can perform some sort of transformation on the data, like log or exponential. In our case, let us drop the record where the value of life_sq is 7478. Removing the outlier value in life_sq column. df equals df.lock, df.life_square less than 7478. 3. Handle missing data. What is missing data? Missing data can occur when no information is provided for one or more items, or for a whole unit. Missing data is a very big problem in real-life scenarios. Missing data can also refer to as not available, values in pandas. In data frames, sometimes many datasets simply arrive with missing data, either because it exists, and was not collected, or it never existed. For example, suppose different users being surveyed may choose not to share their income. Some users may choose not to share the address. In this way many datasets went missing. Missing value treatment. We will start by calculating the percentage of values missing in each column, and then storing this information in a data frame. The data frame PCT_missing_df now contains the percentage of missing values in each column along with the column names. We can also create a visual out of this information, for better understanding using the code below. The output after execution of the above line of code should look like this. It is clear that some columns have very few values missing, while other columns have a substantial percent of values missing. We will now fix these missing values. There are a number of ways in which we can fix these missing values. Some of them are: 1. Drop observations. One way could be to drop those observations that contain any null value in them for any of the columns. This will work when the percentage of missing values in each column is very less. We will drop observations that contain null in those columns that have less than 0.5% nulls. These columns would be Metro Min Walk, Metro KM Walk, Railroad Station Walk KM, Railroad Station Walk Minimum, and ID Railroad Station Walk. Code. Less missing values calls list equals list, PCT missing df.lock, PCT missing df.pct missing less than 0.5, and PCT missing df.pct missing greater than 0, call values. df.dropna, subset equals less missing values calls list, and place equals true. This will reduce the number of records in our dataset to 30,446 records. 2. Remove columns, features. Another way to tackle missing values in a dataset would be to drop those columns, or features that have a significant percentage of values missing. Such columns don't contain a lot of information, and can be dropped altogether from the dataset. In our case, let us drop all those columns that have more than 40% values missing in them. These columns would be build_year, state, hospital beds rayon, cafe sum 500 minutes price AVG, cafe sum 500 max price AVG, and cafe AVG price 500. Code. Dropping columns with more than 40% null values. 40 PCT missing calls list equals list, PCT missing df.lock, PCT missing df.pct missing greater than 40, call, values. df.drop, columns equals 40 PCT missing calls list, and place equals true. The number of features in our dataset is now 286. 3. Impute missing values. There is still missing data left in our dataset. We will now impute the missing values, in each numerical column with the median value of that column. Missing values in numerical columns are now fixed. In the case of categorical columns, we will replace missing values with the mode values of that column. All missing values in our dataset have now been treated. We can verify this by running the following piece of code: df.isNull.sum.sum. If the output is 0, it means that there are no missing values left in our dataset now. We can also replace missing values with a particular value, like -9999 or missing, which will indicate the fact that the data was missing in this place. This can be a substitute for missing value imputation. Analysis of relationship between variables. Types of exploratory data analysis. Exploratory data analysis is generally cross-classified in 3 ways. 1. Univariate analysis. 2. Bivariate analysis. 3. Multivariate analysis. 1. Univariate analysis. Univariate analysis is the simplest form of data analysis, where the data being analyzed consists of only one variable. Since it's a single variable, it doesn't deal with causes or relationships. The main purpose of univariate analysis is to describe the data and find patterns that exist within it. Let us look at a few visualizations used for performing univariate analysis. Box plots. A box and whisker plot, also called a box plot, displays the 5-number summary of a set of data. The 5-number summary is the minimum, first quartile, median, third quartile, and maximum. Histogram. A histogram is a plot that lets you discover and show the underlying frequency distribution, shape, of a set of continuous data. This allows the inspection of the data for its underlying distribution, example normal distribution, outliers, skewness, etc. 2. Bivariate analysis. Bivariate analysis lets you study the relationship that exists between two variables. This has a lot of use in real life. It helps to find out if there is an association between the variables, and if yes, then what is the strength of association. The bivariate analysis helps to test the hypothesis of causality and association. It helps to predict the value of a variable that is dependent based on changes that happen to an independent variable. Types of bivariate analysis. 1. Numerical and numerical. In this type, both the variables of bivariate data, independent and dependent, are having numerical values. 2. Categorical and categorical. When both the variables are categorical. 3. Numerical and categorical. When one variable is numerical, and one is categorical. Let us look at a few visualizations used for performing bivariate analysis. Scatterplot. A scatterplot is a two-dimensional data visualization that uses dots to represent the values obtained for two different variables. One plotted along the x-axis, and the other plotted along the y-axis. Bar chart. A bar chart represents categorical data, with rectangular bars, having lengths proportional to the values that they represent. For example, we can use the iris dataset to observe the average petal and sepal lengths, widths of all the different species. Apart from the charts shown in our EDA example, we can use various other charts depending on the characteristics of our data. 1. Line charts to show changes over time. 2. Pie charts to show the relationship between a part to a whole. 3. Map charts to visualize location data. 3. Multivariate analysis. Multivariate data analysis refers to any statistical technique used to analyze data that arises from more than one variable. This models more realistic applications, where each situation, product, or decision involves more than a single variable. This explains that The majority of the problems in the real world are multivariate. For example, we cannot predict the weather of any year based on the season. There are multiple factors like pollution, humidity, precipitation, etc. Here, we will introduce you to multivariate analysis, its history, and its application in different fields. Let's consider some useful multivariate analysis techniques. We'll look at 1. Multiple linear regression. 2. Multiple logistic regression. 3. Multivariate analysis of variance, MANOVA. 4. Factor analysis. 5. Cluster analysis. Conclusion. EDA is a crucial step to take before diving into machine learning or statistical modeling because it provides the context needed to develop an appropriate model for the problem at hand, and to correctly interpret its results. EDA is valuable to the data scientist to make certain that the results they produce are valid, correctly interpreted, and applicable to the desired business contexts.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.